over to me.
Yes.
Right, over to me. So I have to sit here for a moment just to do some navigation, but then I'll stand up. And I haven't got a lot to show you. I've taken the opportunity to talk about the Philippines now that Naomi has gone. So Word won't get back at the terrible things that I say. But first of all, I just had a thought of taking you to a place which should be under the sea, but isn't. And just to show you a little example of some mapping we've done in Google Reality last year, which was a poster at the EGU conference and which will be written up as a paper. So I think you can see where we are geographically. Here is the Red Sea. Here is the Gulf of Aden. You do not want to be here at the moment. There is a war going on.
Yeah.
You do want to be here at the moment because the war has just stopped last week, officially, although it has not been fighting for quite some time. And this area is famous for the most violent and offensive tribesmen in the world, the Danakil, who turn out to be some really quite friendly people. But one of the reasons of going on Google Earth is that the area is extremely inhospitable. So as we home in, you cannot see any green. It's very hot, it's very arid, and you really have to be a Danakil to spend more than a few days there. They have something that's called the Fire Week, which starts at the end of March and carries on till October, and it's just so hot that you cannot really do anything. And to compound that, oops, let's go back in. It's even hotter because there's black lava. And this area, there are some volcanoes here. I'll show you them. There's one. So I've exaggerated the vertical a little bit here. We are in virtual reality. And the black lava makes things even hotter. 2 geological expeditions, one Italian, one English, disappeared here in the last century, presumably killed off by the local tribesmen, but it might have well just been the heat. And on this volcano here, 5 years ago, a Japanese geologist died from overheating as well. The problem is, they climbed up the volcano in the early morning, when it was cool, they were fine on top, but going down it gets hotter and hotter, and their water boiled, they said. There was one survivor, so they were not able to drink their water. So, if you want to give students a project, you don't send them there. So this mapping was done by Jean, by Roxane, and by Émeric, and Guillaume, sorry. And each of them mapped one side, and what we got them to do on Google Earth was to map the extensional faults, the thrust faults, and any other features of note on this thing here, which is it's a bump. It's like a camel, you see, 2 humps. So it's a hot desert region, so you get a camel. And this in the middle is a rift. This coming along here is a rift. It's pulling apart. So Jamie was here a moment ago. This is a triple junction, and this is an area. Oh, you are there. Sorry, you're trying to hide. This is an area which is uplifting about 2 or 3 centimeters per year at the moment. It's inflating, and every now and then there's an eruption from the side and it goes down. So it's like a balloon. It goes up, erupts, and goes down. But it goes up more than it goes down. And this sort of volcano is one which was described about 250 years ago by Leopold von Buch, a smart German guy, and then got ridiculed because no one could imagine that you could possibly build mountains by inflating from within. But this is exactly it. So this beautiful, I think this is just a work of art. It's beautiful. So let's not worry about the science of this, but just look what you can do. And hopefully this would be even better if we could go in virtual reality and map it. And maybe Jamie, we can go, because I've managed to get to the edge here. There's a little bit of green there, so we can sit under the palms and you can fly your drone. It needs to go 5 kilometers here, do a round trip and come back. Maybe we can walk a little bit in.
You've scared me with all these deaths.
It's a nice place. There are far less people who die here than in, for example, Portsmouth every year from road accidents. You can't die on the roads here because there aren't.
But how many people are there?
How many people are there?
Yeah.
Not many. Anyway, that was just to show you what you can do with a bunch of students in a little bit of time and Google Earth. It would be much better if we could do that, if we could actually go into the virtual reality and do that. So we'll come back to Google Earth in a bit. But first of all, I can navigate myself around my thing. Yeah, here we are. There we are, full screen mode. I'm just going to show you a few things from the Philippines. And a lot of this follows on from what Evie said, but we're going to a place that is very different from Greece. Okay? I think I've told the Filipinos that they're a bit like the Italians of Southeast Asia. They're absolutely crazy, impossible, but they do amazing things. And so this is a map, a simple graph of disasters averted against disasters happened in the Philippines. And the timeline here, that's 2013. They've had super cyclones during this time, and no one has been killed. And you can extend that further. They've had a major volcanic eruption, a big earthquake, and no one has been killed. And there has been damage, material damage, but no deaths. We go back here in the past, when I first visited the Philippines, there was not a nationwide program for averting natural disasters. There was no program for resilience. The different agencies didn't talk to each other, basically vying with each other. And the government decided, sometime around here, they passed a law in the Senate, that everybody had to talk to each other and collaborate. And bizarrely enough, they did. And just after that, there were still disasters happening. They set up a project called NOAA, National Operational Advice on Hazards. And the idea was to get everybody together working. So for example, we talked a little bit about LiDAR and its use. They flew the whole country. They bought a plane, they bought LiDAR, they flew the whole country. And they developed a system of warning for hurricanes, for landslides, for volcanic eruptions that would give them advice in advance. And what is more important, it was to empower what they call local government organizations to take their own decisions. So it's a bit like a weather forecast. You're told that there's a hurricane coming. The local authorities are educated and trained to make their own decisions. The make their own decisions in response to the local conditions, up to the point where the cyclone comes in. And you can see the result, no one gets killed. Except for here. No, sorry, here. This was an earthquake, so it was slightly unexpected. And this was a hurricane that came in, a typhoon, but it created something they didn't expect. In Haiyan, it created a storm surge, which is like a tsunami, but produced by the low pressure of the hurricane coming in, causing the sea to rise and the wind pushing the water up onto the land. So here, everybody did what they were expected to do. In the city, the warnings were announced, and they all went to their storm shelters, and the storm shelters were destroyed by this unexpected surge. So, most of the fatalities were students like you, who knew what to do under the circumstances for what they expected. All the students evacuated to the designated storm protection, and they were drowned. So, things still happen, and things may still happen with the unexpected. But the point is that if you compare the population, then, and if you have a monitoring system which gives you good predictions, then you can avoid problems. I've got a few videos to show you, but I'll go through this first. Philippines, therefore, is a very environmentally impacted country. For example, just south of Manila, they have 8 typhoons a year on average. They know they will be got by a typhoon 8 times during the year. And here's an example. This is not in typhoon season, but Mount Mayon was erupting in January. And here is a picture of damage from a lahar. And I want to home in on this because it's interesting what the newspapers report. It's actually quite technical, the language. First of all, they're talking about lava fountains. In the headlines, it's not explosion, eruption, it's lava fountains. Very precise. Okay, it has spouts, but whatever. It's a relatively banal headline. Then 3 lava fountain episodes were observed at Mount Mayon's crater on Sunday morning. It's a normal Sunday. But rain triggered a debris flow in a stream between these towns and the river, and heavy rain also caused a landslide. So the language they use is quite technical. And on the TV, for example, they were talking about differences between lava flows, pyroclastic flows, surges, lahars, debris flows, hyper-concentrated streams, things that most people in other countries would just not understand. But here in the Philippines, it's things people talk about down the pub. So when Renato Solidum, this guy, he's the head of FIVOS, the Volcano and Seismic Observatory, when he talks, he's talking here, sorry, it hasn't come out so clearly, but he's talking about, he says, if we look at the 1814 and 1897 eruptions, after which signs were noted, everything that we have at the moment does not show that we will have this situation. And he goes on basically talking about these different eruptions and why the precursor signs that we have at this moment are not like that one. But it's quite technical. But there's 40,000 people evacuated. Number evacuated rise to 40,000 already that week. Still not the major crisis. And but they are all getting this information and they are digesting it. They know what's going on. It's helped by people like this. This is my colleague, is Naomi's supervisor as well, Mahal Agbai. And he doesn't run a beauty show. but he does run a TV show in which they talk about natural disasters and resilience. So here is the presenter. He's a bit pixelated there, but he's a local actor, scientist, and heartthrob for the girls in the Philippines. He's one of these sort of boy stars, but he's also got a degree in physics and stuff like that. This is Doc Ted. He's led the Filipino ascent of Everest, and he knows everything about survival. He's got survival gadgets all over him. And there's Maha talking away. So we are in the studio talking about the Mayon event and other things going on, because that weekend there was also religious festivals, which are very big in the Philippines. And Doc Ted was telling what to do if you get into a crush. And I'll tell you, because it may happen to you. There's an earthquake and you all start running out of the building, which you shouldn't do, and you all get into a crush. What do? Get into the praying attitude. It's like being into a religious festival. If you get into this and you get pushed to the floor, it gives you a breathing space, so you can survive. Most people in crushes die from asphyxiation. If you're like that, you protect your lungs. So, that's your top tip. The university is also involved in the reaction. The university has a mandate from the government that if anything, any natural event happens, it must react. So, volunteer fire department, for example, but here is UP Mayon, so UP, University of the Philippines, relief operations. So it's not just the national relief operation that gets going, it's the university. What is the university providing? Just about everything. In this slide, it's dried fish, corned beef, Vienna sausage, empty water cans. Very specific things that people on the ground have said, we need this because of this and this. Very specific things. They were also sending down radio to make a local radio station so people could talk about the problems, an artist, psychologist, many different people, so that you could cover the whole aspects of a society displaced. And by this time, there were 90,000 evacuees. They've now all gone back. So here's another example of what the University of the Philippines does. I was at University of Los Baños, part of the University of the Philippines. Agricultural, they do a lot of forestry, mitigation of climate change, using skills from the forest, non-wood products, in climate change scenarios. Community mapping and planning for disaster risk reduction and climate change adaptation. This is for local government or anybody who's interested. Geomatics. We're missing someone here to show this. Geomatics for improved decision making in natural resources. That's what you did with Vera, almost. But courses for the local people. But not, you might think that the Philippines then has no problems, but there are things to do. For example, here is a map of a trail going up one of the volcanoes. It's not immediately accessible to anybody to understand. This is a bit better. We have a relief image, but still you can get lost in trying to understand what it is. And one of the important things, and this is what Naomi was working on, is studying somewhere like this and finding ways to show the local people what they have up here, so it becomes commonplace to them, and then they can integrate it into their risk strategy. We're going to go on a walk up to here to the mud springs now. I'm not going to show you the mud springs. Oh yes, and just to say that this has just come out this month, Disaster Risk and Reduction Management Handbook for Academic Institutions. Good for us, UP Experience. When I was there in January, they only had one copy, a test copy, but we should be able to get them next month. Luckily it's in English, not in Tagalog. All right, so here's a quick example. There's Naomi, there's Kat. This is a big quarry. There's a truck and a digger for scale, and there are some big rocks for scale. And these big rocks were embedded in this lower unit that they just started digging out, which was a bit mysterious because the big rocks clearly come from the volcano nearby I just showed you, but the bits in between, the fine bit, did not. It comes from the volcano much further away. So we have one deposit made out of things from two volcanoes. We were wondering how this could be. We know what it is. It's a big debris flow, a landslide coming down from the volcano. But why? Up on the volcano, we found the same rounded blocks. These ones are not quite as big, but there are other ones in the stream. So there is Naomi, and this guy, I'll introduce you to in a bit, is Cockroach Man. So we're not just working with geologists. Here's a big block, but it's got vegetation on it. And Cockroach Man is very interested. He only comes out at night to do field work, because that's when the cockroaches come out. But he came out especially in the field in the day, so you can see the rocks with us. And here we're on another deposit. This is the deposit from the other volcano. I'll show you that in a minute. And he was very happy because he found this tree which is being eaten up and a little pile of cockroach leftovers. So the answer for this I will show you in a minute. But to show you that, we have to understand the big landscape. And here is the big landscape. This is the area that Naomi worked on. And it has problems for understanding. It's a vast landscape. It's beautiful. It's far too big to understand while standing around looking. It's got lots of vegetation, so it's difficult when you're in there to see anything else. And there's a huge volcano here that you can't even see. There it is on a clear area. This is a crater lake, one of hundreds around this area. And so it's difficult to visualize and understand that. There are bulges and domes and things, but it's a vast landscape. You feel lost within it. But there are very small things. So here's a nice cutting. There's Naomi again, there's Kat again, for scale. And we're trying to work in a tropical depression. So it's like yesterday in Portsmouth, 20 degrees warmer, just as windy. And what Kat is looking at here is a layer that we were interested in, perched high on this road cut. And it's a tsunami deposit, we think. But to understand that, you need to look at the whole landscape and to work out where it possibly came from and what happened. Above it is a big layer from that big volcano that produced the stuff with the big blocks. So how do we do that? And you can inspire yourself from Filipino mythology. There's one particular beast that they all believe in, a sort of vampire called a manananggal, which is a lady who splits into two and flies around at night. She has an incredibly long tongue, so she can get into places where you wouldn't want her to get and steal things, notably babies, things like that. But one of them stole my mobile phone. It was the only explanation we could find. We went down the police station, and the police report says that a manananggal stole my phone. So they believe, it's very strong. They may be very good at resilience and science, but they still believe in things very strongly. Which is why I think we can inspire ourselves from the manananggal and use Google Earth in this way of getting around like she does and getting into places you can't possibly normally get. So here is Naomi's work. This is the Google Earth. It's all covered in vegetation. If you just go on Google Earth, you don't see very much. That's the city, Manila. But here's a beautiful golden shaded relief image. There's a geomorphological map, and there are various other bits of mapping in there. You can overlay the different things, you can see them in transparency, and you can move between one and the other. And the next step, as I'm sure you would agree, is to take this and to be able to fly around ourselves, like the man of Bengal, and to get into all those places. And you can put images in, so you can go places and you can see things just like we saw in the Google Earth reality. But take it one step further and to use these different types of reality as well. Slope map reality, geological map reality, which help you understand. And with an educated population, as they are, you can take that to the local government, the local school, and it helps them understand their different areas. So for example, if you live here, just about make out there's a deep valley up there. People who live down there, they can't really see it. It doesn't stand out in the landscape. But going with this, you can visualize it. And that tells them they are in enhanced flood risk. They are in enhanced landslide risk if they develop this area there, which at the moment is luckily just farmland. So there's many things to do. And if we get out of that, I forgot one last thing, but we could do that in Google Earth. I'll just show you the videos. If they work. This is just a report from the local newspaper, and I don't have the sound for you, but it's all in Tagalog, so you can understand. Mount Mayon, local reporter, people moving out of their homes. They do it every 20 years or so they're quite used to it. And he's talking about lava. You'll be able to see this morning's eruption column coming up. You notice that no one's really running around and panicking or being too worried. People are going around their ordinary business. There's a nice footing of what we call a pyroclastic flow at the moment. Here it is. This is where the ash is running down the mountainside and covering the land, so they were very concerned about that. So these are all the blocks that the diggers got out. You can see there's so many of them. And the answer to the question was that these blocks come from one volcano. The eruption that caused the debris flow comes from another. I'll show you that on the map in a bit. I was just fascinated by them rolling these blocks into the quarry. And how close that digger was to the edge. And how they happily let us work there. One last one. This is a gratuitous one just to show you the little denizens of the forest. Did you see the leech? Yes, lovely. All right, that's enough for tourist bits. Let's just take you back to here, just to show you. You see this big thing here? That's Lake Tahoe, one of the biggest, the most violent volcanoes on Earth. The volcano we had that big debris flow from the quarry is up here. The volcano hasn't erupted for maybe a million years or so, but it's still dangerous. The last eruption here 5,000 years ago sent large amounts of ash onto this volcano. What happens then? The forest is killed and the volcano is covered by the ash. Without the forest, you get rapid erosion. So you basically clear the volcano of all the trees, of all the big blocks that have collected in the valleys, and you run out down onto the area below. So that explains to us why these volcanoes here have some very weird, large effects that have been caused by this volcano here. The other thing was for the tsunami, we found that deposit just here. You see the lake. It seems to be that this tsunami came from the lake, but the lake was much bigger in those times. And by flying around in Google Earth, we were able to map the old shoreline all the way around, and to map where the tsunami was at that time now. Conditions have changed, but there's still a lake there, and still a possibility for that tsunami. There we are. Now, if you go to Google Earth, forget about where we are now, and we go to, let's take you to somewhere like that. All you need to do, you make your geotiff. It asks you a question, and you have to say okay. And then there you are. It's as easy as that. Of course, I asked Naomi to do this, so I didn't do it myself. And then you can go and visit this area and fly around. So all the images are on the server, and if you're able to get them, what I suggest in the next few minutes is go there yourself, go in Google Earth first and just fly around and see what you can see without any of these, and then perhaps upload one or two of these images and see the difference. For example, can you see the old lake shoreline? Or look at these different volcanoes, see what you can see. But rather than me tell you what is there, just try and see if you can observe odd and strange things, things out of the ordinary that might surprise you. Let's just see what you come up with. So can you do that? Elena, does it work? Yes, we'll give you a bit of time to start. If any, talk them over, put them into your web maps and web stories and stuff like that. So this was just Naomi's example. And what she's gone back to do now is to take this, and she will be visiting the university here, where Cockroach Man came from, and we are showing them these and starting to test to see if looking at this helps in the appreciation of the environment to these local people. The important thing is, if you're not sure that it does help them, then it's no good. So you need to test that. We can do all sorts of lovely things like that, but if it doesn't actually help, it's not so useful. And since we're here, going off, that's the most dangerous place probably to live in the Philippines. And if you do visit this island, you'll see that there are villages and places. The island was completely bare of inhabitation in 1966 after the last eruption, but you cannot stop Filipinos moving in. They're just impossible to stop. So they go and live wherever they want, even if you've got laws and regulations. So the nation as itself may be prepared for cyclones and things in a structural, institutional way, but the society still is capable of creating situations that might turn into problems. And how to deal with that is a Filipino problem, really. Coffee time.
How do you measure how useful this is?
Good question. Difficult. If you have, for example, two populations, and you get a certain number to describe their local environment, who have seen this, and a number who haven't, and you can compare the responses, or you can do a simulation of something, and then compare that, or you can wait for a disaster to happen, which in the Philippines is not very long, and you can see how they react. So that there are many ways, none of which is certain, but we have a lot of also back history of people not being aware of things, so if you can measure their awareness just with a questionnaire, at least helps you to see that they know more. However, knowing more doesn't always help, and that's what's been found out in risk and resilience, that the most educated people in resilience and risk can also be the stupidest, the people who act in the stupidest ways. Sometimes that leads, I know everything, so I'm safe. And they overestimate their resilience. So there's lots of problems along the way with that. Okay. No, stretching. Let's have a stretch and a break.